Hey everyone, I am back. Let me turn down again. My audio here is just thumping in my ears. There we go. All right. So I apologize to those that were talking to me in the last session and I missed that. I'm just going to keep my Streamlabs open this time, and hopefully the chat will not freak out, and I'll actually get to see it. So thank you for the subscription, or the follow, for those that did, and those that joined us, thank you so much for stopping in. If you're joining us now, welcome, of course. And yeah, let's do this. We left off building the finite state machine for the player, and so we're going to continue on that right now. And I don't believe I've touched anything since that moment. So just to make sure I don't bunk it up, let me see here. I need, actually, before I forget I gotta, sorry, with live streaming, right? I've got the live audience, and some of you are gonna be joining us later and watching this in the future. And so until I get all this figured out, it's going to be a mess. It's going to be a mess. So I'm not expecting perfection, and neither should you. But let's share this. I'm going to make sure we can get as many people in here as we can. All right. Oh, that was loud. I'm going to disable my Discord notifications for now. I don't want those interruptions while I'm doing this. Okay, turn it off, and then I get a I get a notification on my phone. All right. So, sorry about the plosive. Let me move my microphone a little bit. I'm gonna get some water here, and then we're gonna continue. Okay. So, when we left off, we had established the left, right, and we were beginning on the up. So we're gonna go into our player manager again, just make sure I have those copied. We don't need the debug manager right now. And we're gonna paste those in. So now when we're pressing the up key, simulate the up button, and again, move us up. We're gonna move this now to down. We're gonna clean these up. Can I get a message in the chat? Can you hear this? Make sure that everything's working. I want to make sure I can read the chat as it comes in. So if I can get a message, that would be grand. Let me... Just kind of waiting for that to catch up, seeing where we're at there. Okay, there we go. Now I have my chat open. Can I get another message whenever you hear this? So now now that my chat is actually open. It was blacked out for some reason. Okay, that worked. Thanks. Appreciate it. Apparently. And then, okay, yeah, perfect. Perfect indeed. I figured out how to get my live chat to work in my web browser. So that's even better. So now I can open up my other worksheet while I'm working. That's not what I wanted to show everyone. All right. Let's see. That taken care of. Close that down. Don't need that. Can I remember? Thank you. There we go. All right. I'm squared away now. All right. So we'll take that off the screen. Also, what did you think of the thumbnail of the last video? It's going to be the same one for this one. Where did I put it? There we go. This one. That looked pretty cool. I did use, because this is live, I did use AI to help me generate the player character, but I think it really does, for a generic placeholder, obviously adding text and some other things, I feel like it captures what's to come, even though we're not doing a 3D game. So let me know, guys, in the future. For those that listen, give me a comment, and hopefully we haven't made that decision yet by then. If so, thank you for your input now, but it's too late. Yeah, I agree too. I do think it's a good representation of where things are at right now. Okay, so to not get any more distracted though, let's get our down keys pressed, and now when we preview and we open our initialization state, we can see that our initialization player script is working because we can see that the idle state is in function. Because normally it says init state, which is our initialization. We haven't moved yet, so there isn't an input to the direction. So now when I W, A, S, or D, we can see that the direction is moving, and then we're entering the run state. And now we're in the run script, and we're changing direction as we're working on it. So what we need to do now is, one, we're going to need to start animating the character because we are actually moving on the overhead, and I think animating from the idle into walking should be one of the next things we do, as well as when we're not touching any keys, going back into the idle state. So the first part of that's really easy. So we have transitional movement, and in this particular case, because we're working in every direction, we're going to remove these transitional movements. We're going to build a new framework, and we're going to take the run from here, and we're going to paste it in here. So if any of these conditions are true, and now what we want to do is invert every one of these. So whether you're on a joystick, a virtual gamepad, a keyboard, whatever our game is programmed for, or all of them, if any of these are true, at any point in time, when none of these buttons are being pressed, we want to change our animation, our player's finite initialization state into, the player's finite state machine. We're entering in the idle state. And let's see here. I really should support GDevelop in the long run, but now you can see that it's all the time. We broke it, right? Because we only want to set it while this is true one time, and we need to take it out of this if statement, the or, because it is only true if none of the buttons are being pressed. It is only true in that circumstance. So let's top that up. Let's do a preview, and now let's check our idle state, and there we go. So now we're running, and now we're idle, and it remembers the last direction. Now, earlier in the first video that I made for the devlog, I said some things that I don't know that I'm going to stick with, because that's the thing about game development. As you go, I am. I've only prototyped some of this stuff, and so we're actually on the fly developing right now. So I do have some experience in developing these systems, and I'm just applying that logic to what I know and inside of the game developer, GDevelop engine. Um, so, but now that it remembers what our last state direction is, we can then, of course, transfer into the correct direction for our movement. So whatever the direction is, that is what the animation sequence needs to be, right? So before I had said we can animate via animation panels or through the animations, like animation number 1 or 0, 1, 2, 3. You know what? I'm just gonna. It's so much easier to show you guys. So in the last session, I had said that because this is animation 0, technically it is animation. I mean, it's animation 0, but in an array we start with the number 0, so 0, 1, 2, 3. And because that it's numbered like this, we can take the animation and add 4 to it. And if we had 4 more animations down here, like run right, run left, run up, run down, and if we keep the same naming conventions, is like idle right, and then the first one's always right, the second one's always left, always up, always down, then when we add 4 to whatever these are in the code, it'll jump to the animation that is on. If we are using animation triggers, like if or like rather than sitting to an idle state, we're saying go switch to this animation. We can toggle those with just by adding 4, because we only have 4 movement directions. It'd be the same if you had 8 directions. You could do it that way. However, I think in this case, now that we have the finite state machine, we're going to be checking when we transition to another state. We're going to be checking whether or not, or whatever the player's direction is, and then making sure that it immediately switches over to that sprite. So that's why we're kind of separating movement functions from character animation. Well, actually, in the player's finite state machine, we'll launch the animator, and that'll actually probably be in the player finite state initializer, because in some development cases, we might create a hitbox. Let's say we're going to play a side scroller game. If we were developing a side scroller game, we would want to develop a hitbox for a container for our player, and that will control all of the mechanics of the player, and then the actual player sprite, so not the hitbox, but the actual player sprite, will then run all of the code for the animation sequences. And in this development, because we're going to be doing some server stuff, I want to take away as much power in that system from letting the player control the input that's going to a server, because then they can fiddle with those backdoors, I guess. And so what we're doing now is refining them down again into those really refined states, and making sure that it's only sending a ping of a player direction, and then the server will know, hey, you need to tell the client to render this. And that way, rather than like every client controlling all of the directions the players are doing, the direction, that information will need to be saved by the server to make sure that we keep players in sync and other things like that. So we're kind of future-proofing. I got dry mouth. So, I digress. Let's get back to our transition. So in our transitional movement, I want to add another, not an object. That was silly. I want an event group. And in that group, we're going to move it down here. And this is the idle. We're moving into a transitional state. We have our main controls. We have our main, under our actions. I'm actually going to pull this out. So under our action scripts, we have movement. And currently that's the only one. We might add, we will add an attacking action or a interact action. And those will have their own scripts. And then the little script sections like movement. And then this is the conditions in which you move out of the state. So in here, when we run our attack action, we'll say, hey, go check the attack actions script, right? And then down here, though, when we'll say when this action is pressed, translate to, you know, like in this case, we're saying move the player's state into idle so that it runs the idle script, move this transition into the attacking script. And then in the attacking script would say, hey, transition back into idle. Or if you have combos, like you want to hit 3 or 4 times or whatever in a row, you need to then add those actions into that movement script. Because again, when we're doing finite state machines, you're restricted to each independent script. They're like a bunch of different little scripts that pile up into a function. And then really all a video game is a polished set of functions that cohesively interact with each other. And so with doing finite state machines, we can kind of target what we're working on, and it's such a micro management level, like being able to really tinker with those fine steps early on. And I think it saves us a lot of time in our prototyping, because like if a script just doesn't work, you know, like the rest of your game works. It's not, you're not trying to tie it into it has a flow to it that you're able to pinpoint where debugging needs to happen, you know, and all of that, I think, in a really cohesive way. There's probably other good reasons why you should do finite state machines, but that's mine. So take it. Okay. So idle transition, we have the idle. We need the animation player. That's what I was working on. So in our player initializer, honestly, I think we're just going to do it in the finite state machine. In the initialization step, this only happens at the beginning of the scene. We need this to always be running. Okay. We might keep the animations in the run script and just create a new event group, and we'll call this player run animations. Because normally I worked previously on side scrollers. That's why I brought it up earlier, and like how you manage them with their collision boxes. But because we're doing a top down, the collision box, rather than drawing a sprite on top of that collision box, they're one unit. So both the movement scripts and the animations would then be one script as well. So some of what I said earlier, like just literally five minutes ago, scrap it. That was I was filling the air, trying to figure out more, talking out loud, telling myself the truth. Okay, this is how we're gonna do this, man. And then forget or realize, no, that's not gonna work. So in this state right now, if the players, I can't add animations if I don't add the player sprites. So run right. We're going to start with our run. We're going to not create. That's too much talent to be efforted right now. We're going to go into our, I think I named it walk when I exported them. Now all of these are in my sprite sheet. I've already exported some of them. So I'm saving myself some time there. So our first one is walk right. So we're going to do walk right. And these are 8 frames. So 1, 2, 3, 4, 5. We have to add them in order or they'll get imported funny. I just got to make sure. No, see, it got imported funny. So now he's walking backwards. So 1, 2, 3, 4. There we go. That should now. Yeah, there we go. So we're just going to preview that. We're going to build a quick script to make sure this works, and then we'll flesh it out here in a second. So the first thing we're going to do is, if the player's variable, because we're working on direction now, is equal to right, and the player is moving, I don't moving is moving. See, it's goofy. If the player is moving and our direction is right, then we want to change the player's animation by name, because I'm not going to do it with the other system, to run right. And then when we're not touching anything, we should go back into the idle, which we don't have to code because we already did. It's independently functioning. So let's update our game. Can we move to the right? We can. Oh, but it doesn't loop. So now, do I need to make it looping? Because now we're doing directional. Yeah, I think so. Talking to myself. That's fine. We're going to work through this out loud together. I just find that when you talk to yourself, I'm hoping throughout this development series that I'll continue to do this. We'll figure it out. But I learn while I'm speaking sometimes. And this is a lot of logic stuff. And I find you find common errors in regular things when you speak out loud. And so manifest it, right? Talk it out loud and see what happens. I'm solving my own problems while I talk. So if you don't like chatter, don't listen, because I'm Peter Parker. I don't know how to stop. Okay. Now, but then I go to tell you something and I forget completely what I'm doing or why I'm even in here. Why am I in here? What did I open this up for? Oh, to loop the animation. All right. I remember now. Stop talking to me, guys. What do you... Oh, it didn't stop. Because we need a animation sequence that says when the player well, the button stop. And if the animation of the player is finished. And the player isn't moving. So just basically, wow. Okay. I'm having a moment. If the player is moving, and we want isn't moving, so the player isn't moving, set it to idle. Moving right. And when we do this, we also want to set the animation. While... See, this is why we normally set... We can do this in a couple of ways, and I'm struggling right now to think of the best way to do this. So we're going to make the idle script 4 times, which is probably not the right way to do this. But idle as well needs to... Oh, no, I know what to do. Okay, we can do this as a subscript. So if nothing is moving, and I figured it out. All right. We need to do this one time. Once, because it'll... No, wrong area. Once. Trigger once. Why true? So now we can get the direction. So if nobody's moving, set it to idle. And then while it's idling, or while we're kicking into the idle stage right after, trigger this one time. If the player's direction is right, set the animation to idle right. Now, this is what I was telling you before. You could do this on those, like, if it's player, player.animation number 4 + 4, like we're figuring out the direction based on animation cues, but now we're doing it via a text variable, which I think is a little bit more cleaner. Maybe. That's my opinion. Fight me on it. Idle left. This is up. Idle up, and then idle down, and then down. All right. So, with any luck, I didn't break it. Let's see. Oh, oh, oh. Uh-oh. Run idle. Okay, he is switching to idle. Maybe we don't trigger this once? Did I not need that? Uh-oh. Uh-oh. Oh, no. Okay, idle direct... Oh. Okay. And that's because... I'm pretty sure that this is happening because I'm looping the run? Oh, no. Okay. That's interesting. I'm trying to figure out what's happening. The animation... The animation should only be playing while he's moving. This is not the right state. We're in idle. Or maybe this doesn't need to be... Maybe that's the problem. And if it's down and the player is not moving, I think I just solved my own problem, but we'll figure that out here in a second. Am I smart? Am I dummy? Am I smart? Oh, left. We're not. If the text variable is right and the player is moving, change the animation. Do this once and then loop it indefinitely. Yeah, okay. So we need to do, I think this needs to be, do this once. Once. And once while true, so when under these conditions, and honestly, I'm going to change this and drag it down here, just cleaner in my head. So when this is true, trigger this once, and we're going to run that. And now we want to endlessly loop this because no, we don't. Do we? What is happening? Okay, we have the idle directions right. So this is right. Wait, no. I'm moving. That shouldn't be happening while I'm moving. I told it to not do that while I'm running. If the direction and the player is moving. Oh, and the player isn't moving. Yikes. All right, there we go. I'm not moving anymore. You haven't stopped. It's because he... I'm working myself in circles, guys. In absolute circles. Okay. Yes? No, but I want him to continue to run. Wait. Up doesn't work anymore. Down, left, right. Because he stopped. He stopped. Set the variable to run. There's a better way to do this. There's a better way to do this. If the direction is down and... Okay, so we need to change up the idle state. If nothing is being pressed, we need to go into this state. However, also, this is just kind of an also situation. If we'll start with right, because that's what we're working on. If right, oh my good golly. Gee Willikers, Batman. You are pissing me off. Alright, right. Right. Okay. So if we are going right, the rest of these can die in a fire for now. So if none of the right keyboard buttons are being pressed, and the direction is set to right, which should only be happening if we're moving, right? Because then it'll go into an idle state. We then want it to play the right animation. So, no. Why is it not working? The direction is right. If nothing's being pressed, right? If the direction is right and nothing's being pressed, this is being overwritten by this. Right? So now, there we go. But that animation is going to drive me nuts if this is going to drive me absolutely nuts, guys. There's in my philosophy of building this character, or building this movement, I think I've left out a valuable piece of information for myself, and I'm trying to figure out what I did. Where are my animations? I feel like I'm not doing my animations correctly. And that's crazy. That's crazy. Okay, so first of all, let's add some thought up here now that I'm thinking about it. So above our movement script, just to help foundate, so there's no issues with our, we want to kind of do double up on the redundancy of some of our, like, to make sure that things are timed right. If the animation, in this case, so like if the player's animation, no, okay, I'm stuck in this side scroller thought space, guys. I'm having issues. I don't know what to do here. So normally, right, if it was a side scroller game, I could run the animation. Wait. Okay, let's see here. If the player isn't moving, right, and the direction is right, do this once. I just borked whatever I just did. What happened? If get rid of these again. So if the variable, we're gonna reinstate this, because when the finite state machine to be controlled by this, and then the animation should be controlled by this. So if the direction is right and the player isn't moving, we want to trigger this once. Trigger once by true. So I think that's what we have to do for the rest of these. And I think that's it, actually. I could be wrong, but I think that was my first mistake. Let's turn these on. Okay, we're going to trigger all these one time. I'm going to put that on the top. That seems like it's an important thing for me to remember. Let's try this again. So if I'm not moving... okay. Hello? If the direction of the player is down and the player's not moving, idle down. Why is that so hard for you to comprehend, my delegate friend? Let's, should those be underneath here? I don't... Is it... Why? 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 Oh, you know what? Maybe this is a great place to say... if the direction is right and the player's not moving and the animation isn't idle right, and we're going to say is not, I forgot to click on that, then trigger this one time. So trigger this once if the animation isn't to the right, and if the direction is to the right and the animation isn't to the right, or the direction is right and the animation isn't already, and the player is not moving. That's what the red means. Okay, nothing. Why? Up, down. Okay, we're running. All right. Let's try this a different way. I think my brain's on the right track. I just, for some reason, am having a difficulty with setting this up in GDevelop. What the heck? So trigger this once. If the direction is right, the player is not moving, and the buttons aren't being pressed. And no, we don't want that one time. We want that all the time, right? What? I swear. Why? Okay. All right. Try this again. Okay. So if the player's variable text variable, again, I'm looking for strings, of the finite player machine is equal to idle. If we're idling, I think I figured my own problem out. So if I'm idling, and if the direction, oh my goodness, direction of the player is to the right, we want to change the animation of the player to idle right. That should just always be the case. Yes. Yes. We are cooking with gas. Okay. That's what I wanted. So, I don't know why that was so difficult. And we actually, I think we just need to do this once. Trigger once while true. Because we don't want this to endlessly loop. It's literally, I'm going to shut my gob. Trigger once is not what I want. I think we trigger once underneath these conditions. Someone's nodding their head like, yeah, fool, of course. Yeah. Duh. Right. All right. Cool. Now let's make sure that works when I loop the player, because we want him to continuously run. Yes. Let go. You're oh baby. Let's go. All right. Uh-oh. He's endlessly running to the right. When I hold another key. That's a weird glitch. But maybe it's because there's no other now I'm like, did I celebrate too soon? Have I forgotten something? Okay. Let's continue to do this, and we'll do idle, and this one's going to be left. And then we'll add the run. We got to run. I was already in the player. I should do that. Okay. So let's add the rest of the player sprites. Now that we have that system functioning, I think, let's go for the rest of them. So run left, run up, and run down. Add a sprite to the left. So left, we don't want idle, we want walk, left, and these are going to be backwards, so we're going to fix that. Import, yep. So 1, 2, 3, 4, 5, 6, 7. That should be a good run. Okay, we're going to loop that. We're going to make sure all these are looped. Add sprite for run up, walk. Same thing. That's annoying, but it might not walk. It might not walk. It might not matter for some of mine because I do walk in reverse. So I guess in my case, it's actually not that big of a deal, except for the up or the down animation. But that's because I drew it in a way that just decides whether you're left foot or right foot dominant, I suppose. Some of them, if you play them out of order, it looks so goofy, but on most of these other ones, it's not really a problem. Move down. Run down. Run down. No? Walk down. There it is. All right. So, 5, 4, 6, and 7. There we go. Let's loop this and preview. Cool. All right. A little fast, actually. To everything else, it's in pace, but I might change some of that because there are 8 frames. So 4, because normally the default frames per second, I think, is 12 on an animation in GDevelop at standard speed. So because we have 8 frames, we don't get as much hang time with every, because there's so many frames, right? Because it'll move quicker because there's so many frames. When we're animating with more frames, we want to slow it down if you want the same pace, or to look like they're running or something like that, you know, they'll be moving extra fast. But let's see. Right. That wouldn't work because I haven't finished this. So we want to now do idle left. And now that we have this, we can copy this one and go, if the direction is left and the player is moving, we want to run left. And we're just going to copy this real quick and do it for 2 more. Call this up. And this one down. All right, for up and down, we want to run into run up and then run down. And now that those are done, we're just going to copy this twice as well. Idle, and then we're going to go if it's up. You know what the drill is. Same thing. A lot of and then a lot of these things we'll be able to copy back, because every time you now do a idle transition out of a run, this should be in the idle script. I don't know why I add that to the run script. That's silly of me. Hey, welcome to the broadcast. I'm not sure how to say your name. I'm gonna call you Alpha. Welcome. If you have a pronunciation for that, drop that in chat, please. If you don't mind. Or I'll call you Alpha. Idle down. Okay. So we're gonna move this here into the idle. So because these are player movement transitions, the actual action should be in idle. That's what was freaking me out earlier. It was taking me a minute to figure out what was going on. So in the event group, right, let's call this actions. And this is where we add that first one that's like, if the player isn't already in an idle position, we're going to idle right by default. Okay. Maybe we should idle downwards. Let's idle. I think we should idle down. Let's idle facing down. So if the animation of the player, by name, if the animation isn't idle down while in this state, we want to do this once while true, because we're going to keep entering and exiting this state. So we actually don't need, we can run a trigger here once. This is just a guarantee. So trigger once if the animation is not run down, and we're in and actually we're going to do this for all 4 of them. So if it's, and we're going to do an or statement here. So just to highlight this, what we're doing is triggering once if the, oh my goodness, okay, run down, and we'll go through the list here. So run right, run left, run up, and run down. So if none of these animations are being played when we are entering this, and the player state, to enter the idle state, we obviously, the player state has to already be there, so we can knowingly make that assumption. But if you wanted to go extra, you could, and maybe, so I don't lie to you and pretend like this is true and then it's not. So let me just add this function. So and then if the player's variable string for the finite player is equal to idle. So we're just double checking that we're in the idle condition while in this state. If it's not any of this, we're going to set the player animation by name to idle down. And that's just our default state. So this should, whenever we start the game, okay. Oh, right. No. Okay. That makes sense. Because of how this is being initialized, right? Whenever we're not running, it's just automatically setting us to down whenever we're in the idle state. Because I closed what I needed. Let's go back here. Because down here, where we're setting these animations, these need to not be here. So that's where we pull these guys out, and we don't need the run animations can be in the run script. That makes sense. But it doesn't need to be in the idle, or the idle doesn't need to be in there. So if we are running, switch the run state. If we're attacking, switch the attack rate. But while we're running, we're gonna add a new group for all these, and we're just gonna call it animations. Animation. In the actions, this actually is above this state. So before the action state, and then transition, but animations on the bottom, we're going to add a new event. Shift W, Shift D. There it is, Shift D. And we're going to paste those in there. So anytime we're idling and our direction, we're going to set those idles. If we are not pressing anything at the very beginning, when we first load this up, idle down, and that way it just checks. And there we go. So when we're breaking that, and this is kind of a good way for us to also test that that initialization of our character, because now we're saying the very first time that we go into the idle state, look down. And we can see that here. And well, I'll open it to show you. And we can see that we haven't actually set a direction yet. So the very first time we're idling, we're always looking down. Which actually for me works out really well. So here we are moving around. We have movement. So, and animation, and better animation than I had before, actually. Yeah. Okay. So now we've got idle working, and we got movement states. And so that's the fundamentals of player state for I think this, hold on, for for our game character here at for TerraFarmers. And so now from here we can start building out the other features. What other things do we want in this game? Well, before we add mobs, I think that we should, let's see here. What should we do? What's next, guys? We can add in some scenery, maybe. That could be pretty good. I think that'd be a good thing for us to do. And then user interface for sure. We're gonna actually let's build, now that we have a player, let's build the option. Scenery will be good. I will do that, but at first I want to get our grid system in place. So now let's do that. So we're gonna go to our game scene. We're gonna go up here to our grid, and this is per map. So you have to do this per map that you're building. We're gonna set up our grid. We're on I'm drawing in a 16 by 16. With offset is we're not gonna do any offset. That might be a problem later. That's a problem for later me to figure out. No, that would be really annoying. I don't think we're gonna do an offset. So we're gonna show the grid. And now our player, because of our offset, should always be, because our player's spawn point is the top left. Now, I think for the player, we're actually going to do an offset of this. So the middle of our character would also be 8.5 by 5, because there is no true middle because of the 16, right? 2 in the middle is how we would have to do the pixeling. This middle breaks the rules of like the 16 by 16, because 8, right, and half is even number. You need an odd if you want a true middle. So because we don't have an odd number and we're going through 16 by 16, it's 8.5 is in between those two things, and we want that to be there. And the reason for that, I'm actually going to get, yeah, no, that'll be fine. So we're going to leave that there. And then we want to go to our collision mask and see, because of our collision box, right, we will bump things that are in our full body, and which is good for like detecting hits. But because we're playing a top down, we might later on use a custom and bring this down just to our body. Let's say this will be 14 just to keep it, or 15 rather. Nope. 13. Yeah, 13. And this is much too small that I'm thinking about it. It needs to be like 8. 9 is better. I'd probably do 10 now that I'm really focusing on it. So this then would allow us to, like, only when our body is hit. Our head can't be hit because, I mean, we want our head to like overlap certain things, but if we do a collision box at the top of our head won't be over top of an object before we run into it, or like we'll run into it way up here, if that makes sense. So basically, like if there's a collision box here that, let's say there's an item we're walking up to, and here's a 1 pixel by 1 pixel up here, we would then collide immediately with our head, and then it would remove the idea of depth from our character, and we want our character to overlap with the scenery and grass and stuff. We want our head to go behind grass, or grass to come up in front of our face and stuff like that. So we want to drop our collision box a bit. And this is where in the other way of coding that I was talking about earlier, with developing a hitbox first and then spawning your character on it, there would be a spawn point right here maybe, or down here, and then the character's sprite image would be drawn on that hitbox. But I think because of this system, we can, and the way that GDevelop handles these collisions, we can do it this way. Hopefully I don't come back to regret that. But we have a weird offset. That's an offset. What's that about? Oh, that has to do with the 8.5 by, what was it, 15? Yeah. Okay. So because of that, I was able to then mark all, I was able to, the player is our grid. And we want to make sure that now I want a kind of a farm selector like what is that game? Stardew Valley, and other games of that genre. When you're reaching out around you, you can interact with the 9 squares in a 9 square radius. And so this will, if we're using a twin stick game, which right now our character only has the 4 directions. Twin stick generally are 8 directions, but I think we're going to add in an 8 directional interaction. So we need to be able to interact with those objects. So to do that, we're going to start building the selector tool. Okay, so let's jump into that. This is going to be interesting. I have a skin for this, and I got to decide how exactly, because again, per finite machines, like while we're idling, while we're running, we don't want to be able to build while we're running. Maybe we do, because we might want to do planting while we're moving, so you don't have to be still while you're planting. So in our idle state and our run state, we got to create a new action that'll be for drawing this this targeting square. So the first thing we need to do is we're going to need to we'll call it an action selector. I don't know why I'm doing it that way. Selector or selector? I think so. ER? I'm dumb. Someone tell me how to spell selector. OR. ER? Oh. It would, in this case, it would be OR. I think. I don't know why I'm so tripped up about that right now. You know when you look at something long enough? Yeah, okay, I thought so. When you look at it long enough, you're like, is that right? Is that right? I'm gonna have to Google it. All right, so we're gonna have an action selector, and I believe I already exported that into my icons, so grid selector or whatever. Okay, and in this particular case, we have an offset. Oh, that's the collision marks. We don't want to mess with that. Let's get out of this. We want our points. We're gonna want to put this at an 8.5 by 8 by 15. Because of the way the offset that we've already put. I think is it 15? See, this is what I was talking about. I didn't need to do this. I don't know why I did it this way. We're gonna fix that. I don't like this. We're not doing that. We're going to for now, let's hope I don't regret this and have to revert it back again later. I want the center of this player to be there, the origin to be the top left, and fix all that so that way now the player will go back in there. Because what I'm gonna have to do if I was gonna continue to do what I had originally planned, every single thing would have to have the same origin point, which is ridiculous. I don't know why I thought that was a good idea. So we're not gonna do that. So we're gonna leave that there, and then let's go into how are we going to build this tool? I know that we're going to need a couple extensions from GDevelop. GDevelop has a massive library of a reasonable library. Sorry, I gotta tell it to you the truth. I gotta tell you the truth. Not sponsored, and that's fine. Anyways, so I want to get back to here. I gotta open another document real fast. I've done this before, I promise. I've done this before. I'm a professional, guys. The action checker. We want... This should actually be pretty straightforward. Now I'm thinking about it. So the first thing I want to do is install the snap. I think there's I do know that there's a rectangular grid snap. They also have a really nice hexagonal one if you're doing like a isometric or a tile-based game or something. So, but we're going to do the rectangular grid. We're going to install it to our project, and now we can access those features. And for now, I think I just need snap to grid. Oh no, I need there's only so much math that this system will do out of the box, and so the extended math feature is what we want. We're going to install the extra things that we can do with our math. So with that, we now get the ability to do things like clamping, which is to set a more permanent I'm trying to think of we can select a range of things and make sure that our numbers are always within those more typical for coding languages. Clamp, for those that have done clamping before, understand. But I'll show it to you in action so that it's not like, what are you talking about, guy? So the action that we want to do, and we are going to need to talk about this actually. So action selector. Okay. In our action selector, we need to decide. This is going to be something we just copy over to all. Like, I'll just be able to copy all this over into the idle, so that way you can also do this while you're in idle. And the selector. Let's see here. We want to at all times. Oh, I know that I forgot. I remembered what I forgot. We need to add some more keyboard input. So the thing we need to talk about is adding keyboard input and gamepad. So now that we're adding more features to our game, we have to start thinking about the controller mapping. And in this particular scenario, when we're on keyboard, we're going to be using a mouse variable. And we're going to be checking if if it can be pressed. And let's see, to do that, I think we're going to add so that all of our keys can be remapped and everything. So we're going to be adding a new keyboard variable. And it's not for keyboard actually, but it would be keyboard mouse, is what we're going to call this, mouse left. And then we can add the mouse click title. And I think I need to check what that is. So mouse button released, mouse left. And I think that it's just called left. Yeah, left mouse button was released. So now we can go back into here and oh my goodness, I got lost. I'm lost. I was going into my global settings. Mouse left, keyboard down. I don't know what this variable needs to be. I'm trying to think about it in my head. What are we gonna do here? For the game, it's going to be really important for the gamepad. And then on mouse, I think that we'll just use the right click variable. Because again, when we're talking about this, we're using gdevelop, and gdevelop has some weird ways to use the interface. So I think that the best thing to do, not gamepad, that's weird. Gamepad A. In this case, we're going to do gamepad left. What is the call out for? Again, we're going to have to trigger left, I think, but I need to pull up the gdevelop controller and look at the gamepad joystick names for things in the code. If the gamepad button releases a certain key, I just need to figure out what that key is. I'm reading the documentation right now. So in this case, we're not using mouse left. We're using or if either of these are true. So if the we don't need to. So we are running. We don't need to check if we're running. So while we're running, if the mouse left, I didn't need that or. If the mouse button is pressed or touch held, if the mouse button is pressed, mouse button release text. Text expression. Mouse button. Rudimentarily, I think this will work. We need to add a or, which is actually in here again. Okay, so if the last mouse button is pressed, or the controller, any button is pressed, buttons pressed. If the left trigger, I think that makes sense. So in a controller, if the left trigger is down, it'll enter the build mode, right? And then right trigger will be to attack. I think that's the thing that makes the most sense in my head right now. So left trigger 2, so L2 on your controller, is on gamepad 1. I don't know why. If either of these are true, we need to set the position of this object. So the position of the action selector will be set to the position of the player, and we're going to do player X. And we're going to do player X plus the clamp radius, like the clamp. And so let's look at this real quick. So you have a min, a max, while we're doing this. So the value input that we're doing is for a min max. So what we want to do, because this is a 16 by 16, is we want to take the direction of, let's see, we want to take clamp. This needs to be lowercase. I don't know what this music is right now, but I'm vibing for it. So clamp is -14 by the mouse. This needs to be capitalized. It's -14 mouse X. This is fine. I haven't finished it's telling me there's an error because I haven't, player X, right? 14, yeah, okay. I was like, wait a minute, that should be right. So we're taking the mouse's X position and we're minusing the player's position. So that's the between -14, which, because we're doing a 16 by 16, -14 is off the player by X amount. So if the player's in the middle, right, we're looking on either side of it. So we're clamping this between those two directions. And we're saying that it can go left or right at this much. And now for the y-axis, we need to do the exact same thing. No, okay. And then we're going to do, instead, we're just going to do y. And we want to do mouse y to player y. So now we can go up and down. And then once we have that in place, we also want to change the Z order. So Z order in GDevelop is a top down, or is a layer system. So if we change the Z order of the action selector to be the same as the players Z order. Minus, so this is how we guarantee, so the Z order of the player is, in this case, 0. So with Z order, we can do Z order minus 100. Z order, capital Z, capital O. So now it'll always be at underneath the player to a certain amount of, like, to 100 layers. And I have a naming convention. I just do 100. You could put -1, and then whatever's -1 will always, like, it'll always be underneath the player. If the player is 0, foreground, background, negatives, positives, whatever. So this gives me a lot of room to wiggle other features in around that. So we're gonna eventually in the finite, actually we're gonna do that now just because I am thinking about it. We always because this initialization is constant. We want to add it to our player finite state because it's kind of always scanning for these things, and at all times, and we'll add it to the initialization. At all times, we want the player's Z order to be the value of the player's Y position. And so basically, as things are listed, so if we're looking at an axis and we have +1, positive is up here, and this is the x-axis, this is the y-axis. I'm a visual person, so maybe I just draw this for you guys real quick. So effectively, if you've seen a graph axis, right? So with the graph, we have y in the positive and y in the negative. Other way around, y in the negative, y in the positive. No, GDevelop is like this. Come on. So and then it's negative and positive this way. So if the y value is forgot what it was. Oh, the Z order. So what we're going to do is we're going to set the Z order. So because 2D doesn't have depth, right? We're not in a 3D environment, because then Z would be like perpetually this line backwards, right, into a 3D space. Right now this is 2D, but if we pulled this into a 3D space, this would be a field, a plane in front of us with a big expanse behind it. And if we draw on that line, like say it's coming towards us and behind us, that's the Z-axis. And so in this case, we're saying if we're assigning a fake Z order, we're saying in the layering system, because now layers are done like this because we're in a 2D game. If we have our tile set that has, here's our tiles, and then our player, whatever. Each one of these is a different value on the y-axis because it has a location in this grid that we're building, the map that we're building, right? So our whole level is this grid. And so we're saying at this point, draw this square. That's our tile. Like once we add tiles to the game scenery, that's what that is. Now what we're saying is we want the player's y point, which if their origin, right, is up here, we're taking it from their origin point, and we're saying, hey, whatever this value is, that's what the depth of this system is. And this adds a fake 3D, or the idea that there's depth in the game. So this will, with the way that we set up our boundary, we're saying that if there's a tree here, right, and it's that's the best tree I've ever seen, and we're up here, we want, and if we do the collisions and if we set this up properly, we can make it so that the top of this tree is based on its Z order of down here. And so when we move behind this area, it draws on top of us, and when we move in front of it, we draw on top of it. Right? Yeah. So that was a messy way of explaining that, but hopefully that helps. So now the Z order of the player, rather than being on a base layer, is now moving between the different fake layers, or until we start adding them. So right now it's just it'll constantly being set to whatever my Z axis is, or my Y. And so we can also, if I do run into any issues now, because we have a Z ordering system, I can have the Z order printed in the debug, and that way while I'm playing, in testing out my features, I can see what the z-axis is, and then I can test when I run in debug mode, like where is that tree exactly, and this will help with collision masking and other things. So anyways, now that we have the basics of our movement in and our selector, we need to add, so what works here is, one, I don't want this to be left mouse button, I want this to be right mouse button actually, and it's not when released, it's when held. Right, and we need this to be pressed or touched. So when right, I don't know if you can see it right now because we have so when these are true, for now I'm gonna get rid of this for now. Let's just work with the mouse and then we'll work off that. I gotta minimize what is causing this stuff to happen. So I just don't know if I can see it right now. It might be there. It might just be so white that it blends in. So, oh, no, I have to add it to the scene. Right. So now, oh, what happened? My character's running in weird directions. Let's go check if our player is moving right, run right. If our player, oh, this was actually in our movement script. So press right. So if left, go left. If right, go right. If up, go up. And yeah, okay. So we have left, right, up, and we have up twice. There we go. And now we should have down. So up. Oh, no, when we press down, we go up. Why is that? If we're pressing down on a... Oh, that's why. Silly. All right. Now we got it. Okay, so down. So now we have this clamped, right? Whenever we press right, it'll snap to one of these directions around our player. But that isn't working very well because we haven't, it's staying on the map and we haven't clamped it to a radius around the player. Because I messed it up. Let's figure out what happened there. Okay, so first of all, I'm chaotic. So we're going to change the action point, the origin point of this to be in the center. And then we're going to go to our selector. We're going to add a new script here, and we're going to snap object to a virtual grid, because it's not gridded right now, right? So we're just saying spawn it randomly within the player's vicinity within these circumstances. That sounds awful. So we're gonna now snap it to a 8x8 grid, or not an 8x8, a 16x16 with an offset of 8x8, because if you want to be really technical, it should be 8.5. I mean, it's a little bit over, but like, I mean, you meet in the middle, right? So, but we'll do 8x8. And we'll preview that. And now we should always have what is happening here. Okay. Well, first of all, this should be 12. I believe. Okay. Okay. Why are you being... Oh, it's only when I'm running. Because I'm a mad genius. All right. So we need to go back to the idle state. And in our actions, we need to add the action selector. Because that's something we can do, right? So now... Yeah, there we go. That's better. I can't go down. up to the up left. What is this? Is chaos. Why is this happening? Maybe if I go up more. 1, 2. I can't go down. Wait, why can't I go down? Because it's the player's origin point. This is the top right. And then I offset. Okay. So I need to stop what I don't know. I just told you, I was like, I'm chaotic. That was dumb. That was dumb. We don't need to do it like that. Because I set up this, I need to get in the origin point on this and fix that. So don't do that. Don't do what I just did. That was dumb. No point in doing that. And I also just, that was the wrong point. So we're just going to delete that. And this needs to be 0, 0. Okay. So now that we have the selector set, oh no. What's happening? Every time I move, it's gone. I don't know. Okay. But that's around the player now. Except for, I think I do need to still have an offset. 1, 2, 3. 1. Okay. Okay. Stop what you're doing. So while it's being held, stop the presses. This is not working. So 1, 2, 3. 1. It's because of the corner, right? So I think I do need to move. 1, 2, 3. What's happening? I'm inside the square I need to be in. But maybe if I stand in the middle. See, if I stand in the middle, because my point is up here, so the player needs to be on an 8x8. I need to move. I think earlier I was right here. And for the sake of my own sanity, we're going to put him in the middle. And that should, see? Oh, did I do it? I don't think I think I did it. I can't go down until there. Yeah, you know, that almost works. I think that'll be fine. So now what we need to do is in our game scene, and actually, you know, now we have a debug manager. At the beginning of the scene, we want to hide the action selector. Hide that, Snappy. Hide that. And then we want to, when we click the button, while we're holding that button down, then we want to draw it. So I'm trying to think here. Yeah, I think that we can just add it right here. Right. We're gonna have to add it to both of them. But right here, when this button is down, we want to show this thing. And let's add this to the top so that we see that's right away. Honestly, I also just want to change the position and the Z order after we snap, and change the position, and on right click always show. No, we're not gonna do that. Give me just a second here. We're gonna undo that because that's not what I need to do. These are conditional, but we need, because we're doing more animations, we need to make an animation section. For now, because ain't nobody got time for that, we're going to add this, and we're going to say when it's down, always show. And when the button is now released, to hide it again, right? That, I don't know why I did that. I gotta fix this now. We want the action selector to be hidden. So now my game doesn't work. There we go. So now when I'm in the idle state, I can select around me. Look at that. And you got to be kind of standing in a good spot to be able to select everything. Because if it ever bugs out, you're just going to... Wait, why is it staying? Okay. Because, again, right? So, I'm going to add this to the section. So, I don't, it just should be there. I don't know why. I don't know what I'm doing. I don't know what I'm doing, guys. I'm an amateur. What is happening? So we're going to get rid of this action selector. We're going to add a new one into our actions. Now that it has the animations built into it. Just one thing. Great. Now we can do this. Perfect. Not perfect. 1, 2. 1, 2, 3. There we go. And then when we move, it'll do the same thing. Because we're controlling it from different states. Again, but this is kind of the thing. When you create one of these things, you just copy it over. I'm going to keep saying that over and over and over again. But that's how easy it is. Like, yeah, it's a little bit more finagling, but then you really isolate what is happening. And this is the fiddling that you kind of have to do when you're doing finite state machines. Because we're moving between various states. It gives us, make sure that no button pressing random buttons in certain states just don't work. Like, that's simple. You don't want to be working on a feature where, this is how you have to separate W. W can't always be moved forward. You have to define what these keys do. Like if you're in a cutscene and now you're pressing that key, this is what happens. You have to really break that down. And when you don't have these in separate folders, separate scripts, it becomes a muddled mess. It's very hard to start, in my opinion, getting all those tools kind of together. This is like the polished way of doing it. And again, per my perspective. I'm not an authority on this by any means, but I seem to know what I'm talking about, right? Right? Okay. Let's see here. I just like that format a little bit better. Okay. So, let's see. Okay. Next step. So we have the selector working. Yeah, okay. So the next thing I want to do is work on the terrain. Yeah. So we're going to create a new system in these events, and we want to make a world generation. We're going to have procedurally generated world, guys. So, one of the first things I know I'm going to need to do is, of course, create a new script. And we're going to call this world manager for now, because I don't know what else to call it. Add that to this and change this to world. Come on. Oh my goodness. World manager. Oh, sorry for my alarm. All right. Let's see here. I'm going to swip these around so I can see more clearly when somebody types. Because it's more constantly in my view. I had to set up another monitor. All right. So the next thing I want to do is develop a world generation script. So at the start of the game, we need to go into our world, our debug manager, actually. Oh no, I gotta quit clicking on this thing. I'm breaking stuff. So debug manager. In our debug manager, I also want to add a string. Let's see. We're gonna add a new line. So new line, and then plus we're gonna call this seed, and we need the code for our seed string. So what we need to do is we're gonna add another extension to our game. I know we need the noise generation. Yep, install this. All right, so now we have the noise extended features. So with the noise extended features, we can add a seed, and in that seed, we can to string noise seed, and we're gonna end that with one of these. So to string noise seed. So now when we update our game, and okay, well, that broke everything, didn't it? So now that we're in our game, we can see that we have a seed. We have a seed, and we can when we restart our game, it'll be a different seed every time. So this is so we can share our map data or anything we want with our friends or whomever. So the next thing that we're going to do, now that we have a seed being printed, we also want to collect that seed information to our world manager. So, all right, let's begin this. We're gonna add a note up here because I might forget that the seed information on debug manager. All right. Now let's create the world, the generation. So generation. Now inside of that, we're going to add our first script, and we are going to set up a comment here that says set grid. We're going to set the grid properties. And so at the beginning of the scene, oops, where is it? Beginning. At the beginning of the scene, we want to generate noise. So create, let's go noise, and we want a noise generator. Create a noise generator, and we're going to call this generator because that seems appropriate. And we're going to do this on a 16 by 16 generation. So we want the actual, we need to add some scene properties. So in our game scene, I'm making some realizations while we're doing all this. So we need to add some properties. We're going to go to the scene properties, and we're going to add some new scene information. So this we want to be baked into the actual game and not the player's control. So if we were to put this in like the player's settings or somewhere else, like global variables that you're interacting with, that could cause, like, allow people global access to those things. So what we want to do is create a scene. So it's baked in here. And that scene data is, we need a size Y number. So we're going to add, that's that. We're going to set that to, it can just stay at 0 currently. Size X, and honestly, I might set these here because we want this, when we're generating our noise, we're looking at how big of a section we're kind of like looking at. And so we're going to do a, set these variables to 32, a little bit bigger than our actual tiles. And I'll show you kind of how that comes together here in a minute. We also need an X, and I think we need a Y and an X. and these are going to be lowercase, so we don't want it to get confused with the actual systems things. And so I'm just trying to think if I need anything else. String, we're gonna add number 1 here, and we're gonna do a number 1 as well, so row completion stuff. So let's go here into our world manager. We're going to generate the noise. We're going to change, this is a variable, variable. And now we're not using globals. We're using general, or in this case, scene. So we're going to go to a number. We're going to go scene. There's actually scene. I don't even know what I'm talking about. Where is it? Variable. We don't want number of an object. We don't want that. Hold on. Generate scene. Change the text variable. Scene variables. There it is. So we want to do this to 32 and 32, and then we want to text. What am I doing? Number. Thank you. I don't need quotes. I was like, what? This looks weird. All right. So now we're going to setting that to 32, and we're going to take the size X and do it by 32 as well. It'll all come together here as we get working on it. So the next step is we want to be able to, for debug purposes, so here's, we're going to add, we also need to add another scene variable called looping. Scene properties, property. We need, this is a Boolean. This can go up here. We can call this looping. Looping. And Boolean set to false. Okay, so next step here. Now that we got to finish our grid properties. So now that we have generated, we're creating a noise generator, and we're setting the scaling of that into a 32 by 32, which is twice the size of our scene. I think there's a reason in my previous figuring out how to do this, I did 32. I can't remember off the top of my head right now, so some of you might be wondering what that is about, and frankly I can't remember, but there's a reason. There is a reason. And so in this next one we want to do an or statement. So at the beginning of our scene, we want this to be true. So if it's the beginning of our scene, or it's when we're in the debug, we're going to use our keyboard, and so or mouse in this case. Let's do middle mouse button down. So if the mouse button was pressed, and we're going to do middle. So if the middle mouse button is being pressed, or at the beginning of our scene, we want to now generate the noise of our seed. So now this is like how much static there's going to be, and that defines the overlapping. There are plenty of other tutorials on like how to generate Perlin noise and how that system works. And what we're doing here is we're going to be taking two layers, and we're going to be taking a base layer and a top layer. And as we're going to be checking if those tiles are correct, and if not, they're going to adjust themselves to make sure that they become one like cohesive terrain tile. And so this is how we're gonna test that for peaking and depth, and each of those layers will give us finite control over like how grass spawns and everything else. So we're getting into scenery now. So obviously we're generating the world. So yeah, we need to add a noise. We need to add noise, and we need a seed, and we want to do a random in a range. And so this is between two numbers, and we want it to be from 1 to 9, like something ridiculous. Okay. And And in this case, I don't know how far you can go, but I feel like that's too many 9s. Let's shorten it up to, yeah, to the millions, right? So now we have this number being generated. We are going to be generating that noise and putting that into that text. So eventually we're going to grab this noise. Right, in the world manager, we are generating the seed, and now we're taking that noise seed that we're generating here, right here, and it should automatically do that. So because they're running in the main scene at the same time. We haven't initialized the world manager yet, but we will. So anyways, so now that we have that, we need to set the X and Y on a 1 and 1, which they're already set to that. We want to make sure that they're set there. So we're going to change the scene variable. So grabbing the scene variable, text variable of Y to 1. This is the number variable. There we go. Text. I hate, I'm going to keep saying this. I do not like that they're called texts and not strings. The naming convention is the same everywhere else, guys. Why? I think it's to be user friendly. I get it. I totally do. But it drives me bonkers. Yeah. Okay, so we got that set, and we want to set the Boolean to the looping to true, because what's going to happen is we're telling it to on this grid to kind of go through it, and as it does, reset, and because it's scanning effectively in the seed to loop through and generate our map space, and so we're going to take this and set our scene to loop. So scene, this is a text. This one is the text. Change the text variable of, it's a Boolean. It's not a text. What am I talking about? Oh, guys, I'm getting tired. You do this constantly, and then your brain just wants to turn off. It's okay. So now, when we preview, we can look at our seed, and we're getting as we can tell, we're actually getting why is it doing that? Interesting. Why is there a period there? I didn't break this, did I? Random, change the noise seed, float. That's not right. That's why. It's when I was typing this in, it auto selected. So we want it to be random in range, and I think that's what I said when I was creating it, but I must have just pressed tab. So a float number is a number that has a point value afterwards. And in this case, we want an in range, which are whole numbers or full numbers, right? We don't want partials. We don't want fractions and crap. We don't want that in here. So now I can generate this, and in between 1 and a billion, effectively, we can randomly generate these numbers. Now, these seeds, this is just like if we loaded in, any sort of like Minecraft or something like that, where we're a chunk-based system. And so that's what we're kind of building here. And so now that we have the seeds, whenever I press the middle mouse button down, we want to do this one time. So we're going to do this and say once. Trigger once while true. Because I don't want it to keep rotating while I'm holding the number down. That could, if I do get a good generation, I don't want it to accidentally delete it, right? If I'm holding it down. Because that's human error. All right, so now that we have that, we have no tiles to generate. So now we need to add our tiles. So now we have the basis done there. We're going to add a new bit to our system here, and we're going to call this one tile. These are our tiles. And now we're going to assign these tiles based on a transparency. So what we're going to do is we're going to take one tile, and this is our main tile system, and all these tiles are the bottom. And then we're going to lay another one called biome on the top, and the biome is going to be decided, or in this case, the variations. So think of it like adding texture on top of a painting. And so the background, the back tile is our backdrop, and then everything on top of that. And so we actually take a top layer, and we using a Perlin noise color map to then assign, like, at this peak be brown, at this be yellow. And I think the best way here is to just kind of show you. So now we have a tile, and our first one is our blank. And now it isn't actually a blank. This is our we're going to call it not blank. We're going to call it default. So our default tile for grass in this case, because we're going to do I'm going to try to make one cohesive biome first. So this is our first tile map for this biome, and we're going to add in some sprites. And so now I have exported some tile set stuff, and we're going to start with just what I call grass. So now we have a grass tile. Okay. That's going to be our most common made tile that's printed out. Now, what we're doing is we are going to control animations for this tile. So rather than generating a bunch of different entities, it's creating one entity overlapping, like generating in a cohesive range of each other. And so now that we have a default tile, we can start adding in our biome or our elements. So this is what would go on top of that tile. And so let's see here, we want, let's say we've got spotted, which is a light graveling, and then we're going to do gravel. So we're going to call this spotted, and then we're going to create a new one, and we're going to call this gravel. Okay. So we have a default square, a spotted square, and a gravel square. And these are just kind of textures. So now that we have this tile system, we want to generate a duplicate, and this is going to be called color, or color's fine. Color's fine. It could be named. You'll kind of see what I'm doing here. So now with this, we need to add another one, and this needs to be a blank square. So there will be nothing here. And we're going to call this one transparent. So the transparent layer, which there's nothing on it, is going to be changing hues or brightness. And as it becomes more translucent or less, it'll then choose a tile. And so that we don't have an error there, this actually does need a sprite. We need to set this to 16 by 16 and resize that, and then just save this, because this is transparent. There's nothing there, but we want it to save that file so that way we don't. I'm full of garbage. I don't know. I thought that would have saved. Does that not? Do I actually have to like add some alpha transparency? Which I don't see a way for me to do that. Transparent. Okay. Can I just fill it with transparency? Are you gonna let me do that? Oh, there we go. I just had to click save. I'm smart. Don't worry about it. Okay. So now that we have this, we're gonna go back to our world, and we're gonna create another comment, because this is in line of our generation. After we generate a map, what do we want to do with it? If we generate a new one. So if something happens here, and we press the button again, what do we want it to do? and we want it to delete the old map. So old world. So now we're going to add a condition that if we do this, trigger this one time, not only does it trigger this one time, but it's going to trigger this, and we're going to delete destroy. We have to click on what we want to destroy. So first we're going to destroy the tile. Can I... What? Delete, not destroy. So whatever. So we're going to delete the tile, and then we're also going to delete the color. Okay. Okay. And that happens now every generation. So what we can do is now our next step. So our next step is going to be, now that we have a generator that's running and is developing the noise that we need to extrapolate on, we can now draw, we'll draw the grid, because this really is a grid. And now that I'm thinking about it, we're gonna, because we're drawing in squares, right? So that's what a grid is, or like a uniform array of boxes. So while these conditions are true, so while these conditions are true, while true, repeat these. Okay, so while true, while is a while loop, right? So while this, couldn't remember where it was. So while the conditions are true, and what condition are we checking? We're checking the Boolean of looping. So if the scene variable Boolean for looping is true, we want to begin our looping process, and only do this while we're looping. So the first thing we're going to do is start creating our first layer. And I need another variable for seed, I want to say. And to make it so it's not confusing, we're going to add a property, and we're just going to call it S, a number property for S. And we're going to do number 1 for now, because that's what I'm going to use, just like the XY, XYZ, XYS in this case, because we're developing kind of a seed pattern. Anyways, so we're going to create an object, and we're going to create a tile, and we're going to position that at the origin of our tile, which is the top right corner, or origin dot x. We got this. That's not right yet either. It is right, but it needs a lowercase o. Oh no. Yeah, I got this. Okay, so I need an origin cube, duh. So we can generate, but where do we begin generating? Do we generate on the top corner of the map? Do we generate on, so we want to make, sorry for yelling, it was kind of loud. We want to make a new sprite that is the origin of our map. We're gonna call it origin. Sure. Later on, we could use a point. Like, we could define this point that we're generating from based on the player's position at the start. And we're gonna do that, but we're gonna do it by well, it's fine. I'll learn you something. Here we're gonna add this, and it doesn't matter what this is called. We're gonna just name it default. for simplicity's sake, and we need to turn this into a 16 by 16 so it matches our grid. And we're just going to do this in black, just so we can see it. Save that, apply it, and now we have an origin cube. So what we're saying is at this position of origin x plus 16, right? So every time we loop through, we're creating a new tile at a 16 because that's our grid spacing, multiplied by the scene variable of x, because we're creating at a location, so we're creating at the x variable first, which is, we're starting with the first location, and then now we want to do the same thing for the y position. So origin y, oh my goodness, origin y plus 16 times the variable of y. And this is just we can set these up here. So we could, we're adding these scene variables. I guess depending on what type of generation we're doing, we might increase the multiplication to create like a bigger grid, especially if we're scaling things. So in this case, unnecessary, the way I went about it, you know, we obviously, it's like multiplying by 1, so you're going to get the same value. But yeah, we're not going to worry about it right now. And so we're going to create another one of these, and we're going to do the same thing for the color tile. Okay. So now that we have a tile and the color tile, what we're going to do is use the noise generation on the tile, which is going to be on the top, and well, in which is upside down in this case, or the bottom, technically. Whatever. We're going to set a opacity level based on the generator. So the reason why we use X, Y, and S is more or less for these variables. As we change this is where that opacity comes in. So as we change the X and Y, as we're multiplying, it changes the densities and things like that. So we, you know, on bigger squares, it's more uniform, things like that. But in this case, we're kind of clamping the opacity. So I'll show you what that looks like. So we're going to change the opacity of the tile, and this is where extended math comes into play. So extended math, and we're doing map, because mapping is that let's see, map noise, and you can see here actually when I type map, we can kind of look at it. So we're looking at what the lowest is, what the highest is, and what we need to convert. And so the first thing that we need to do is, we're talking about the convert value. So we're going to be we're placing in math into map, and then we're adding our brackets, right? And inside of that, we need to pass through the noise. And we want the noise 2D, right? We're generating noise in a 2D space, and we want to pass the generator into that with two other numbers, the generator string and then the coordinate. So the coordinates will be variable x this is a lot of math, x divided by variable, because I'm doing 16s, I guess this wouldn't be necessary. If this was in 32, by 32, this would be more important, but because they're all ones, it doesn't mean anything. I can end, like, I'll show you the intent, like how it affects everything as I change the seed in these variables. So variable x divided by variable s. And then we need another set of numbers, which is variable y divided by variable s as well. So y, that s is out in the open. I don't know what he's doing over there. Do this and then do variable. This needs to be a capital. Oh, variable, no, variable. And this needs to be s. Now that we have those, we can now add the coordinates and opacity. So basically, negative 1, 1, 0, and 255. This needs a closing bracket. There we go. Like something is wrong here because this is all inside of the generator, and then we have to close that up and then add our original thing, which is the highest range, and then the lowest range. So we're passing in the seed variable, multiplied by itself basically, and then we're talking about adding in the opacity between these. So 0 to 255 is going to be, which is black, or like completely 0 is completely see-through, and 255 is full presence. So whoa, that song change was sudden. Let's go to figuring this next stage out here. How are we going to do this? We also want, because we're repeating these, right? So at the end of the line, when this is true, we want to, or when this is done, this is to generate one tile effectively. And so while we're looping, we want to tell the system that we need to, once this is done, loop again. And so right now it'll keep stacking these because we haven't told the y-axis to move over by one tile set. And or like one path. So what we need to do is and this is why the seed in the x, y, and seed variables are important here, because we're going to be cutting these things and making sure that they snap into the grid and generate properly. Getting tired. My explaining skills are starting to go down the toilet. The next thing we want to do is change the scene variable. Let me make sure I clicked on the wrong way because of my brain right now. So here we got scene variable, scene, change the number variable. This is a number, y, and we want to set it. We want to add, not set it. We want to add one because we're moving along the y-axis, and we'll do the same thing with x, but we're generating this way, right? So from the it's actually top down. So plus is bottom, negatives. Earlier I drew a picture. Negatives up top, positives down here. So in the middle, we're gonna go from the top of the square. We are adding 1 every time we go through a circuit, and we're dropping down that list, and we're checking things to it's gonna be generating like top down. And then when we reach the variable size, when I'm greater than that, it's going to, so like we're drawing the columns. Now we want to, on the end of a row, move down and one column, move down and one column. Otherwise, checking like this way, it's doing this. So inside of this area, right, we need to add that condition. So now we got some generation going. Actually, this would be a great time to, it should just show you. Oh, or I'm going to break everything because we don't stop generating. We're infinitely generating. Which, oh, these are the number of squares we're generating. I remember now. So we're going to be generating 32 by 32 squares independently, independent squares. Like this is how many it's generating. So we could do 100 by 50, 100 by 100, and that'll be like a big playing field for our biome. For now, we're going to be generating our biome chunks in 32 by 32 of these grid squares, right? So when we're saying is +1, it's going like X and Y. It's going to go down this way and over this way. We're generating from this corner, from this cube to the next one. So we're generating off of this one, and then yeah. So that's why this was important. Now we're going in here, and instead of deleting the old grid, we are on the end of a row. Draw next line, or draw next grid. Line works. And in here, we're going to create another one of these. And now, when the number, the scene variable number, so when the number variable of y, because we're adding one, right, is every time we're, I keep trying to write it out. What we want is greater than. So if it's greater than the variable, the global, or the scene variable of size y, because again, this is where the size matters. So funny. That was so stupid. Y. There we go. There's spacer. So if the y is greater than size y, we need to set it back to 1, because when we're moving, when we're developing our grid, right, we start at the top and move down. And now what we're saying is set it back to 1 as we move over on the next axis, on the x. So y all the way across, and then down, and then y all the way across, and then we're going to keep going in that direction. And I think it's actually it's down over 1, and then down, and then over 1, and then down, and then over 1, until we fill out the grid. So, and it happens ridiculously fast. But so now what we need to do because of that is we need to set the y back to 1 to make sure it moves back to the top to start over again. And then we need to rather than we need to add an x now, because this is at the end of that row. Move on to the next one. And now that we have x, we want to add 1. And then because we're still in a loop, we have one more layer to go. And so we have this one, and then we're going to take this guy and add it down here. And now this is on the end of the grid. We want it to stop the loop. Stop looping. And so if the x variable, right, in this case, if x is greater than the variable size x, because we don't want to do, we don't want it to, we want it to finish all 32, because if you do greater than or equal to, you'd only have 31 lines. So we need to have it set like this. So at the end here, we don't need this. So when the x finally reaches the size of the x, I could probably name these better, but so I know what's happening long term, but I guess it should be fine. So we're going to take this, paste it, turn it to false. So now, before any coloration happens, before we start filling anything in, we should this is what we have, because our tile, and we're getting our tile, these blue ones, but the whole thing is blue technically, but we're using that transparency tile What am I using the color for? Oh, the tile is the background, and then the color on top is like it's so we're reading these colors, and then we're going to take our color palette and we're going to start painting this chaos. And there's so many values that are happening here, like 0 between 255. We're going to take a cluster of them and to start making our biome. So now that we have that rolling, we're going to add the color, and then I think I'm going to end the broadcast after I add the color. And we'll work on more of this another day. So here we can see that some of these tiles, because they're independent tiles in the game, are being placed at a Z order different than the player, right? And this is what I was talking about before, adding depth. So this whole tile, it's judging where my feet are. And once my collision and everything passes that, then I'm drawn under it because of where my origin is. And that's why we want to now set the axis to its own Z axis. And so we always want these tiles under a Z order. So we want these tiles to always be underneath the player in depth, right? Before we add any more color. So now that we're in here, what I want to do is set the Z order. So always in this case, we want something to always happen. At every second that this world has been rendered, and once this manager runs, which it'll be pulled once I interesting. Wait a minute. Where am I running? Oh, I've already set the world manager. Okay, yeah. So when the game initial, I was like, wait a minute, where's that? How's that running? We're gonna move this up. World generation is important. So while the world generation, whenever it runs, these will always be kind of, the script will be running because we're telling it to always initialize that scripting. And so what we want to do now is always, so we don't add anything here, not at the beginning of the scene or anything like that, just always. We always want the tile to be at the Z order of, now we could set it underneath the player, but what I think we want to do, I could be wrong. So we're going to test this out first, is we're going to set it just like we did the player to their Y. The Z order is set to the tile's Y, just like we did with the player. And now, I believe, we should... Well, that debunks that idea. I thought that for sure. Oh, I also need to set the color, because we also do the same thing with this, don't we? We're setting the opacity of the tile. What am I even using color for right now? This is important, and I know why I need it. I just, for the life of me, my brain is telling me to change this. So they're both being generated. We're creating the object at the same spot. We always need a background, but then the color opacity. Okay, this has to also... we also need the color in this generation to be the same. I'm pretty sure. Oh, no, am I wrong? Or is that because of my Z order being weird based on my top? I think, no, I moved the player's feet down here. Okay. You know what? Yeah, you know what? This is what we're gonna do. We're gonna set it to the player. The player's player dot z order minus 99. 101. Sorry, I'm going in the wrong direction. So these need to be the same. We're going to set it to that as well. So now, no matter where I am, it'll always be underneath. So the reason why I did that at 101 is so that I can keep this rolling, right? So we want it to snap to these grids. And you know what I want to do? I'm going to increase the distance because I'm not using full collision on my character. These are snapping weird. As you guys can see, I keep not being able to go down. And I think that has to do with in our selector while we're idling. For now, I'm going to remove it entirely from the movement script, just so I can fine tune it and then push it back out. So, okay. In this selector, the clamping, I think I should have just done the full 16 by 16. And then I think on this as well, I can do 16 by 16. I think, yes. Yes. Okay, there. Much better. I don't know why. Why did I do that? I don't remember. It's in my other script, and I don't know why I did that. But now it actually works. No matter where you're, I mean, like, as long as you're in that square now, rather than before you had to be like way down here. Now you can more reasonable. That's way more reasonable. Okay. And then we want to make sure we bring this script back over to our run. So in our actions, action selector, action movement. There we go. So now it'll again yelled at you. My bad. Now I can select all these squares. So perfect. So now we have our selector squares working, and we have our player movement on this grid. And it's generating as it should. So our chunks are going to be 32 by 32. And then we're going to kind of, I'm going to add points on these chunks. And if I'll add some collision checking, and if they are outside of the zone, add edging, or we can blend into another biome, or generate, at the end of this, at the very top, we want to create, or on the corner above this, we want to create a new origin to then create a new seed to create an endless running. I love that this is called Spry Genes. I didn't name this preview. That's hilarious to me. That is funny. It's just, I don't know why I just noticed it, but that's funny. All right. So yeah, our selector works good. And now it's time to start coloring. So here comes the fun part for me anyways. Ooh, I like this movement. Has a little bit of a kind of a slide stop, which I think can add some wacky movement fun later on. But I might, because we're in space. There should be some sliding in space. Okay, that's fine. I might fine tune that later. We'll see. So now that we're generating the grid, we need to add one more. And we need to add a new event group. We're going to call this coloring the map. And I'm calling it color because we are using a color scale. We're by kind of fading. We're already working with colors, so it makes sense. But you could, if you wanted to generate like just one biome, or use these depths, like one map. I'm going to be adding another generated, eventually, color, and then if the collision value, let's say if this is going transparent at a certain depth level, because of the noise. So basically, within this noise range of light, we can have all of this to be regular dirt. And then what we want to do later is I'll add another color and then do another set of blending. And then we're going to be looking like if it's grass, if it is a blank, plant a tree randomly, and that an interactable. And then we can use that to spawn various stuff based on these nodes. And one of the things I want to do as a concept is each of these squares, I want to add a point of I'm going to add a sphere in the middle, and we're going to use a array system to check a line of sight. And so if the player has it has a sight range, and this will be important later on with mobs. If the player has a sight range, or I guess in this case it wouldn't be the player, it'll be a mob. If the mob has a sight range of, let's say, 6, 1, 2, 3, 4, they can see us from here. What we can do is build these the individual, because each tile has its own ID already, so we can kind of assign it with these orbs, and basically, just as a visual example. And so if the creature is within line of sight, 10, 6, whatever, it'll move towards the player, right? But then we kind of want to add, we want it to be a radius, an array radius. So it's constantly checking everything within its line of sight in every direction. And so it'll be able to tell, the creature will be able to tell how far it can see in that radius. And then what we can do is save that location that it last saw the player when it turned to false. Let's say that if it was always true, it would be able to see through walls. And we don't want that. We want something to break line of sight. So we need to create a system where not only is it testing its range, but certain objects block its ability to see outwards. And then that way we can save the tile set where it last saw me. So let's say I was running from a monster and there's a wall here, and the monster loses track of me. I can run this way, and then maybe the monster, to be more organic, would come visit the last place. And then it's still scanning, because then if it finds me, it'll start moving towards me. But if I didn't do that, it would just endlessly move against the wall. And we don't want the AI to be dumb. We want it to feel juicy. And so we're going to juice up the AI later. But we're in this grid drawing. I'm going to add a point where each of these tiles generates one of those debugged orbs, so we can see the line of sight when I develop the line of sight script. So, and then we can color coordinate them. We'll make it a gray orb. If it's green, the creature can see you. If it's yellow, it's on the edges of its sight. Yeah, give it some spice. And then also if it's, then it'll save a last location, and it'll be per creature. So, and then we can kind of mess with that, because then we can, let's say if you have a spawn location and your creature's in the middle of that spawn location, because that's where you put them in the game, or the game generates them, it'll look at those 9 sites or whatever that range is that it can see in all of those orbs, and it'll be allowed to move to any of those positions and then move off of that to the next position, but not further than that. So basically, if I was to draw this, and I'm just going to use these tools very simply. So let's say that this grid is our map. And, oh my goodness. Okay, so this is our map. And each and every single one of our map pieces in the middle has this, this light to check it, right? And so here's what that looks like. This is the line of sight. So this would go on top of our grid for every square. If the player is occupying, okay, we don't want all of that, but that's okay. So basically, for all of this is ridiculous. Let's say our monster is spawning in this location. We're gonna color that red. So here's our monster. Our monster can see 3, or 2 in this case, in every direction. So 1, 2, 3, 2 this way. That is not what we want. We want to make sure that all of these are independent. I must have missed some when I was randomly clicking. 2 this way, 2 this way, which means this one 2, 2 this way, it's for me, this one 2, this one. And we're building this 2x2 grid around our player. 1, 2, 1, yeah, okay. So here we are. This is not right. We don't need this one. This one's wrong. Okay. Oh, that's why. Doop, doop. Okay. So now we have the character's visuals. So imagine if there was a tree or something right here. That would block your line of sight. So we can just add a black. And so basically by building the system, our AI can look while it's moving, and every time it moves, right, it'll this square around it will keep moving. So these will always be like they'll be there, and then it's checking in its line of sight if it can see that. And if now what I would do to make an advanced AI is then take this idea and then make it so that way the creature can move to the outside and then move within that range. But as it goes, we might do like a spawn radius. So let's say we're making like a weight decision for our character or our enemy. And so when they spawn, this is their grid that they can, as we can see, that's the grid that they can move in. Now we want their max sight or max movement range from spawn to be like double that. So I'll just go out here and kind of mock up what I'm talking about. So let's say that this is that. And so each of these squares still has their vision, but the further they go from their spawn location, the weight will be to pull them back towards these original ones, but they can move to, and if we wanted really dynamic, we could go 3 layers deep. So you have the spawn radius, the movement zone, and then the weight to return. And so that way your creatures, as you are building this, this sight range sort of map, they can move within this range comfortably. They'll move around everything between here and here, and they'll still be scanning, but then as they leave, they might come out and then go back in, and then come out and then go back in. And that gives us kind of a movement pattern that'll end up looking kind of like this with the monsters, but then also they'll move anywhere in here and not care at all. Like, this won't make them come back in. So we'll have on the outsides, we'll have that this going on, and then on the inside it'll be a lot of this random whatever they want to do within that weight. And so yeah, they'll be able to move out here potentially, and then move on. Or we can at the same time take this system, move it to this edge, and then allow them to move within those grids. But anything out here is where, like, beyond out here is where we get that bounce back. So from here, if they can see 2 out, they could then move anywhere in here. But then anything beyond that first step is weighted to return. And that way you don't get monsters that roam super far, but at the same time have a realistic or at least some sort of logic to their brain. And then we then add collisions that block line of sight, like walls and things like that, and then they can move around it. Because if there is a wall here, it knows that it can go this way to go around it, because this would also be blocked because of its vision, and the same with this one. And so it knows that it has to, once it moves here, has to reevaluate. Is there something there? Yeah, don't go that way, go this way. And that way there's this subtle, like, they'll go to the edge, and rather than just running into the edge, they'll start riding the edge until they find a way around the object. If you're still within their perception range. That was a long explanation, but what I really want to do is get this done. So I'm almost done here. Okay. Let me know if any, what you guys, if you guys watch this video later, let me know what you think. If this is, helpful. Obviously, these are long videos, so I don't expect everybody to watch the entire thing. That'd be madness. But if you'd like to see how games are made, then this is the way to do it. Let's move into making the coloring the map. Sure. So we'll call it ow, whoa, ouch, yow. Oh, okay, ow, that hurt, but we're fine. My elbow, I put it on the edge of my table, and as I moved my elbow back, it, like, my funny bone rolled over the edge of my table, and it sent this painful shock all the way up my arm. My bad. So we want to map the tiles to terrain noise. Something like that. This is more for you guys to see what I'm doing. Also, I like to be really organized, as you guys can probably tell. Clean code. Make it so people can read it, understand what's going on. And if you can't understand it, go back and do it again. Okay. So, if the opacity of the tile, so we're going to start with opacity. So if the opacity, how bright or translucent or opaque is the image, right? If the opacity is greater than, it's less than, let's say 150. So if it's less than 150 points, we want to generate, and it's in collision. This is where we're starting to layer those the color on top of the tile, right? So if the color is in collision with the tile, and it will be because we're generating them on top of each other, we then want to paint them. So we're going to set the animation, of set the animation by number, set the animation by name, and we're going to, the color is going to be set to default. So now we can see that because there's nothing else for us to argue with in the system, I love the way that this kind of slides. I think that's going to add a lot of fun. So now with all of this, if it's below this, color it this. Well, there's no other colors for us to test against, so of course it's going to overlap. I think that's true. If I do a tile, I don't think that it's going to change anything, but I just want to make sure that I am not speaking out of my head. Okay, yeah, that's what I thought. So change the animation to default or grass or whatever. So now that we have that, we need to start adding in the extra depth. So we want this one to then start at what this one left off at. But this one is greater than. If you're greater than 150, but you're less than whatever the next number is, and we'll say 180, maybe. And so now between 150 and 180, we have a common thing. And actually, yeah, I think that'll be fine. We'll set this not to default, to spotted, right? So now we have, what's this? Oh, terrain. We have generation happening. We have differences. And if we press our middle mouse button down, I feel like, feels a little slow. Is it continuously generating? Did I forget to? It feels like it's checking too much. Like suddenly, or maybe not. Maybe just now that I'm seeing my character movement on the board, it's freaking me out. Let's add another tile. So now this is again 180 to 200. And we don't actually want gravel for that. So now we come back in, and now we can see the changes, right? But it seems like we're getting a lot of we're not getting nearly the amount of, we want this to be reversed, I think. Let's try that generation. So let's try this as default. This can be remain spotted, and then this will be gravel. Did I do it backwards? There we go. That's much better. Okay. So the closer to the end, the full opacity will be what's more important. So now we have, now we have terrain. We have some sort of, man, I'm telling you, there's something happening here. My frames don't quite feel like they should. we're gonna run this in debug mode and find out what happened there. So now that we're in debug mode, let's refresh this. That's a lot of tiles. That's more tiles than we should have. Right? 32. But that's both. Yeah, that's not right. This would be 32 squared. So that's 32 by 32 by 32, right? No, I'm dumb. Hold on. 32 by 32 would be length by width. But that's length. No, that's right. Okay. I'm just running to my brain. Don't worry. I got this. Developing without a math brain is trauma. And there might be, I mean, we're generating such a small amount of, like, there's so many chunks, so many individual tiles, but it feels like it's not stopping. Like, it is stopping, but it's still trying to process. And we don't want that. Let's real quick in our world manager, before we do this, let's go back to our game and see how it feels. Okay, hold on. I just came back and now it's running at, was it just generating? Is that, oh, okay. That's trippy. So as soon as I turn this back on, it's so chunky. Yeah, we can definitely see how, like, we're a huge loss of frames. I don't know why it's struggling so bad right now. That doesn't make sense to me. That is so choppy. But then when I hide the opacity, maybe I need to set the tile too. Let's see if maybe there's this overlap that's happening where it's like it's freaking out because, oh my goodness, maybe they're like clipping and it's just freaking out the system. So let's just set them both and see what happens. No, that did nothing. So that's not the problem. So we get rid of the tile then. That's wild. What caused that? Whoa. Okay. Maybe because this one isn't at 255. Let's try this. Maybe if I set it. Oh, no, it doesn't like this one. What's wrong with my default tile? Am I doing like too big of a gap? Like what is happening? I don't understand. No, it just doesn't like the default in. What? What's happening? Honestly, you know what I bet it is? It's all the Z ordering I'm doing. Because that has to be it. That has to be it. No, yeah. That has to be the problem. because what it's doing is every time we're layering, each time we're adding in this difficulty, we're losing huge. Okay. I'm full of my own shit. What? What is happening? What is happening right now? Let me make sure that drawing the grid, we want make sure looping is false. Yeah, that's good. Y set to 1, add 1. Native 1 1 for 1 something like that. That just clears things up for me to visually see. All of my variables are right. Variable. Let me double check this. Yeah, that's. I'm not. Wait, hold on. Oh my god. Okay. It's legitimately like it's this tile, but I don't understand why. But if I change this to default, now we're running fine. Okay. 181? Maybe there's just like, it doesn't like the overlap? No. Why is it doing this? I'm gonna try restarting my development suite. Maybe something weird happened there. Relaunch GD. Wait, did I even close this? Close this. Gdevelop. There we go. Oh, I guess I did. Oh, why? What's happening? Let's see here. Generator. False. Tiles. Okay. Let's try Ooh, I did it again. Ouch. Rolled my elbow. Blank. Greater than 120 tile gravel. We want this. We're gonna do this in the way I planned on doing it from the beginning, but we need to set tile. So 128 to 145, right? 140, 14. We're gonna call this spotted, and then 145. We'll do 145 to the end game, which is 255. Or we'll just say that. We'll just say that actually. Hold on. If it's greater than, it'll just be the gravel. Let's check that out. Nope. I legitimately have no idea what tile. Let's maybe it has, I feel like it has something to do with the tiles. Like I'm missing something here. Tile. And this can be gravel. But that, I don't think that's gonna, that's just, what if it's not color? What if it's tile that needs to be, no. No. Okay, so I had that right. So we don't need that at all. We want the color to return and remove the tiles. Okay. We don't want that, and we don't want that. All right. Man, I'm not sure what is causing this. Bottom top. Delete the tiles as we don't need them. If the looping is true, create these. Let's change this size. This, maybe it's a rendering issue. Maybe that I got something going on in my PC, but that doesn't make sense. Oh my goodness, that's not good. So 16 by 16 runs fine. 32 by 16. Let's test it. Okay, still fine. No problems. Except for, again, let's swap these around. Gravel, spotted, default. Okay, playing around with this small biome chunk generator. Okay, that's running fine. And then 32. And now it's dead. Okay. What if, okay, let me zoom out. Maybe I'm thinking about this the wrong way. Maybe it's the camera. Let me zoom out to just regular. And no, it is just, that should not be a problem. Something is happening and I am unsure about what it is. Preview in the debugger. We're moving, but there is substantial problem happening here. Refresh. Nothing happening here. They're not moving. All their Z orders are fine. Let's get a profiler. That's shenanigans. We have so many lost frames, it's not even funny. Don't tell me you don't have any lost frames. I'm looking right at it. Oh, shoot. We gotta do that again. All right, preview, debugger, run the profiler, run around. Obviously, we got a problem, and stop profiling. I don't know what any of this means. Oh, response times. 100% apparent. That is. We don't have an attack yet. So that makes sense. Oh, okay. We can see the world generation. Yeah, I mean, 74 milliseconds isn't that big of a deal. I don't get what's happening here. I guess let's see about adding a few more. Just I don't know. Let's I don't want to end on this note. That feels weird. So let's come back in here and see if we can't. I'm just gonna add a few more textures, I guess, and we'll see kind of what happens. So tile, we're gonna add another sprite. Call it. Maybe we'll go sprout. Or we'll name this grass. Okay. So that's grass now. We need to do the same thing for this guy. Actually, I don't know why I'm adding all those to the tiles. The tiles doesn't actually need any of them. Now that I'm thinking about it, I don't think so. Because of let's see about that. I'm gonna try it 2 different ways. Hopefully I don't break the system. Oh god. All right. We're gonna call that grass, and we're gonna import that into our project. Okay. So now that we have this, that's broken. Oh, wait. Wait, why did that fix the game? I didn't even add another color. Did I? What? What happened? Why are you suddenly working? Camera manager. Go back to 3. Preview our game. A little bit of chop there when I'm generating as I'm running around, but what? Nani? What happened? Whoa. Oh, okay. No, that makes sense. So, if this is bigger than, okay, so that tells me that we have to be careful about. We actually want to be generating more noise, more tiles than we do when we don't, because there's so many of these tiles that are like default. I don't. Wait, why is that though? They're 2D pictures. That shouldn't be a problem. I don't know. Because if I say this is 160, right? And we go in here, and no, it's running. It's running just fine. So the amount that it has to draw, I think, was killing it. That is wild. That's wild. Well, guys, actually, I think this is a perfect spot because then we can come back and start working on the in-depth terrain on our next video. So thank you guys so much for stopping in, hanging out, and vibing with me this entire time. I really appreciate it. And I'll see you guys around next time.